Welcome to our next webinar. This is our 206th webinar in the series, the sixth year that we're doing these, and they just keep getting better and better, in my opinion, and adding new important technology and new important tools from AiM that come out, and that's going to be what we're going to talk a little bit about today. We're going to talk about the new EPM0832 devices, adding power outputs to your device. Our guest today is Robbie Yeoman is going to join us. He is joining us. And Robbie, thanks for joining us again today.
Yeah, good. Happy to be here. Excited to talk about the EPM. I think it really enhances our product offerings. It allows us to grow a system as the user grows. So I'm really interested to get in there, show you how easy it is to set it up, and what you guys can expect when thinking about or purchasing one of these devices.
It is a very, very cool next step in the evolution of what we're doing, and I think a lot of people are, if they haven't heard about it yet, they're going to hear about this a little bit today and understand where the value is for them as well. So we will jump in and talk about that a little bit. Robbie, tell us a little bit about yourself. Don't worry about the slide too much, but you got a beard on. You don't have a beard. You have half a beard today. So
I'm somewhere in between today.
Exactly. Tell us a little bit. You've been here for quite some time, and one of our best technicians, obviously, and been around for quite some time. What can you share a little bit about what you're doing these days?
Well, these days I'm working a lot on development and really trying to kick off the power distribution side of things. So we have new hardware coming, or we always have new hardware coming out, but the power distribution is kind of a different section of data. So while it is a data logger, it also opens a world of possibilities to someone who's building a race car or someone who's racing a car. And it takes a little bit to get something like that up and running. So I've spent a decent amount of time doing that. Luckily, my passion has always been racing. So making race cars go around the track as fast as they can is something that I really enjoy doing.
Absolutely. And these PDMs, while very, very powerful, very, very technical, and some folks are used to oil pressure and water temperature, and that's it, and they don't understand how deeply this power goes. So it's always interesting to talk a little more deeply about this. So we will kind of start off with, and by the way, those of you that are here live, if you have a question, go ahead and throw the question up into the question and answer box. Well, I'll try to follow the chat box, but if you have a question that you have that you think Robbie can answer here today, throw it into the question and answer. I'll be following that along, and we'll slip those to Robbie when we get a chance. And for those of you that are watching this later, on YouTube, a recorded version of this later. Anything we talk about as far as links and different things will always be in the description of the video. So anything we talk about here will be available to you in the YouTube description. So Robbie, let's talk a little bit about. Give us a little bit of background on AiM power distribution and histories and differences and things like that. Talk about that for us.
Well, we've always been a data company where we had data logging systems, and we always had some type of control with digital outputs. I mean, going as far back as Evo 4s with the digital out to activate a relay based on conditions that you wanted to activate. So if we wanted to turn a fan or a pump on, we could trigger a relay. But there's more to it than that, and there's a lot more than we need to do with just one relay. So the PDM was just the next logical step into developing this full package, this full AiM ecosystem. The PDM really opened up a lot of doors for people that are building race cars. It allows them to not only have a data system with the data logger built in, the supplied GPS module, but it also allowed them to now affect things with data. So in your sump pump example, without stepping on your toes for the next webinar, the sump pump example is a perfect application for a power distribution module. We're recording engine RPM as well as oil pressure. Now we can define like a nice set logic that says when oil pressure drops below this, activate my sump pump. I don't have to keep it on all the time. I can actually have it queued up and ready to go and to provide the provisional oil pressure. So the EPM came about because systems develop over time. Uh, you get a racer who knows that he needs data to make himself faster. Then they want to develop, or maybe they want to switch classes, and there's things that have to be added or taken away from vehicles. The EPM allows you to modularly grow within the AiM ecosystem. So you can have your data system at first, and then when you realize that you need a little bit more, or you want to start affecting things in the car based on that data, you can now add an EPM system to it. That EPM is going to allow you to take the data and marry it with a doing function, a power output or a close to ground. Something now is affected in the vehicle, and it can be as simple as turning on lights, but it could be as complex as killing the engine if the car like rolls over, or something happens. You have a fail-safe mechanism to shut the fuel pumps off to turn potentially volatile situations into a nice safe application, and it's all automated.
And even I hear some of your examples sometimes is maybe a car has two fuel pumps in an endurance car or an off-road truck or something, and if the draw becomes too much or gets too warm or something, it can fail over to the second one automatically, and the driver inside of the vehicle doesn't even know that it's done it, right? It's all handling that automatically. Just another powerful tool that these things can do.
Yeah, the hope is to free up as much mental faculties from the racer that we can. So automating fans, fuel pumps, anything that they would need to flip a switch for or hit a button for can now be automated based on this data collection system that you already have in the vehicle. So that's really
so really the depth of what you can do is really just held back by your own imagination sometimes. When it gets deeper and deeper into this, right?
hmm It really does. The benefit of the EPM is just the growth, and that's really what I want to kind of show you guys today is how you can take an existing data system and grow it into a full car automation device. So we're not going to spend too much time on the automation side of things because we do have a couple of webinars where we discussed how to build a PDM system, how to make status variables and stuff. Today I just want to show you how easy it is to take your existing data system and add an EPM to it.
And which systems can actually support the EPM?
Any of the 1.2, 1.3 hardware systems. So if you have MXS 1.2 or 1.3 or an additional, even PDMs, they're not on here right now, but the PDMs are also compatible. So you can run dual PDMs when one PDM is not enough, or you want to, a lot of times we'll need to locate the power source, so we can run a larger gauge wire to provide power, but then we don't want to run long legs of power throughout the entire vehicle. We can now make these modular areas, front, rear, or cabin front, to give the wire run short. It makes harnessing a little bit easier as well.
Perfect. You ready for the next slide?
Yep.
There you go. Talking about how to put these things together and stack it all together. Here's an example. Kind of talk us through this a little bit.
So in this example, we have a primary PDM32 that is the brains of the operation. This is going to hold your configuration. It's where you're going to plug into it with the USB cable, and it's also going to run the display, be your data logger, provide you with lap times. That's the brain. The display for it is really like I was liken it to a computer setup. So you have a PC that does everything, and then you have this user interaction. That's the display. So it's a very lightweight display. It doesn't have a whole lot of electronics behind it. It's just meant to show the user information. It's optional. You don't need the display. Most people will option for the display because there's not a lot of electronics. The cost is relatively low compared to a data logging system.
And the driver still wants the lap times and the RPM, or whatever it happens to be, right? So
now the interesting setup that we have here is that we have a secondary PDM. So when one isn't enough, you can always add another. Now the EPM gives you another 32 power outputs to then play around with, and they share the same power requirements. So you have low power outputs, high power outputs, medium power outputs, half bridge power outputs. They're all identical, and the pinout for them is similar. Now, the important thing that you have to mention, and I've made this mistake once, the EPM does need an ignition turn on. So it's important to share the ignition turn on between these two devices, or you get a delay in activation of your of your secondary device. In my mess up, I had the PDM32, and then I had a power output right next to where I located the EPM. So I just told the master PDM32 to activate the EPM, and it was a an inherent delay. It would be a much better approach to add the same ignition turn on, so you get a unique activation event, not a staggered activation event. So it just everything turns on at the same time.
Should be in parallel, not in series, I guess.
Yeah, so you
Probably
can
the
see
right
in
way to
the
put it.
connection example, there's two legs coming off of that key input. One of them is to feed the master PDM. The other one is to feed the EPM, but it's the same local source for turning on.
There you go.
And then the data hub is everyone's familiar. I hope everyone's familiar with the data hub. That's going to be how we link the two devices together, and it's very similar to how you would add a keypad or a GPS module, a Lambda controller, any of our CAN accessories. It's going to be expanded upon using that data hub device.
And then you can double stack or triple stack those as well. Just as usual, just as
Yep.
normal. Okay.
And so the EPM is pin for pin compatible with the harnesses that you would make for a primary PDM32. And that does mean that it carries with it all of the analog channels. So not only are you adding 32 additional power outputs, you're also adding 12 additional inputs, the 4 digitals, the 8 analogs, the dual speeds. So it enhances your car significantly.
Wow, gives you a lot of options at that point. Okay.
So here it just kind of touches on what we were just talking about, the EPM, the RGB LEDs for both devices, the 08 and the 32, are used for quick assessments of what's happening in the vehicle. So you have a green, a yellow, or a red power output LED. When you turn a power output on, it naturally turns it green if everything's fine, yellow if you're overcurrent, just slightly, but still manageable, and then red if the logic has been triggered to disable the power output. So that means you've activated it, but something's happened within it, and we need to look a little bit deeper. So those RGB LEDs are a really quick way to just look at the PDM and kind of understand, is there something wrong with my vehicle? If you see all greens activated, then all of those power outputs are working the way that they should. The analog and digital inputs, these are fully configurable, and they support all of our sensor family lines, and you can also use the external sensors with the custom sensor manager. So really the only requirement is that it outputs a 0 to 5 volt signal, and then we can map a sensor curve for sensors that don't belong or that aren't in our database. Now, our database makes it pretty easy. You can get a 0 to 150 PSI pressure sensor and select it right from the list, and away you go. It's as simple as that.
Again, if you're used to using an MXP or something, you're going to feel at home when you are configuring and working with the EPMs as well.
Mm-hmm. Now, the digital inputs, they do have pull-ups and pull-downs, and that's the same as the EPM. So a lot of this is going to be a direct walkover to from a PDM to an EPM. We're going to see a lot of similarities. It's just going to consolidate the configuration into one device, which is wildly beneficial when you have multiple PDMs in a vehicle and you have to program them independently, and you have to kind of remember which power outputs you're managing, because you're going to have to edit the configuration of that specific device. In the EPM's application, you don't need to manage them separately. They're all within one configuration, one home, one USB cable, and it simplifies the process quite a bit.
And that's, of course, when you're mating up an EPM with an existing PDM. But if it's just as straightforward if you're mating up an EPM with a 1.3 device, right?
Mm-hmm.
You're talking about the most complex. To bring it down to just adding an EPM to a normal display.
Always, I tend to go to most complex situations.
That's what we do when we get questions and things, right? But it's fairly straightforward.
Yeah. So the compatibility for John Barnum was asking about the compatibility for PDM and EPM with other data logging systems, and the PDM would be compatible. We would take in information from the other data logging system through the CAN bus, and it would be like very similar to connecting to an ECU. And as long as we're getting the data in, the EPM is designed for the AiM ecosystem. So right now, the PDM can be grown and used for other data systems, but the EPM is going to be only used in our AiM ecosystem. So it requires some type of AiM device to control the configuration because it doesn't have one of its own.
Perfect. The analogy, you mentioned that analogy, but maybe just as close of an analogy as a SmartyCam 3, right? You can use the CAN input outputs and use that with a number of different data systems as well.
Mm-hmm.
Okay.
Yeah, very similar. We try where we can. We try to make things as open as possible. We've seen a lot of our open devices, open keypads, open Lambda controllers that allow you to go outside of the AiM ecosystem with our technology on board. So it's a wonderful option. The EPM though is it needs to be as simple as possible. So providing a configuration for that would be it would take away from the simplicity of it.
Yeah, there you go. Okay, you ready for the next slide? You're gonna finish that one.
Yep, ready.
Okay, you were talking about them being the same, the pinouts and some other things. Let's take a look at a PDM32 next to an EPM32.
So these same amp seal connectors that we use, the main differences that you're going to see are in the USB input, the reverse camera input, which is the Bender connectors on the right hand side, and the LVDS cable for the display. So the EPM is minus those. However, the footprint for this is exactly the same. So an EPM32 fits in the same mounting position that a PDM32 fits in. You don't have to change much of your design, or if you're designing in CAD, then this is a direct replacement for that device. So mounting it somewhere else in the vehicle, making brackets becomes a little bit easier. It's just trying to keep it as similar as possible. So it's just PDM32 minus three connectors, same Surlocke connector. Now you will see some reserved inputs on the EPM, and that is because there's no need at this point to have a CAN 1, a CAN 2, and an AiM CAN with power and ground. So we still have the AiM CAN lines that will connect the two devices, but because they both are power distribution modules, they receive power in on their own. They don't require the VB EXT, which is part of our AiM CAN bus to operate accessories. So when you connect these two systems together, you're using 3 wires. So you're using the AiM CAN high, AiM CAN low, and the ground between them so that they can have a shared ground plane. Other than that, it is a direct swap over.
Okay.
All right, so the EPM's Race Studio 3 8.1 was a significant overhaul for our software, and what it did is it remanaged a lot of our systems like MXSs, MXPs to share the same type of logic that we use at the PDM level. So you'll notice a huge programming increase to the status variables, to alarm management. They're all going to share what we were doing with the PDM already, because the PDM kind of requires that nesting Boolean logic and ORs, and to be able to stack them so that they work well for you. The 8.1 makes all of those systems share it. So now we can kind of go from an MXP to programming a PDM, and you're not going to need to relearn how these operations are done because it's all the same.
I find the more higher level of integration of that way of thinking, I find that even more logical for me personally, with the this and or this, and and keep stacking them. That it works better for me anyway. So I found it was less complex for me.
Yeah, it made it more consistent for me. I know both. I was comfortable in both aspects, but when you wanted to do something, you had to really understand what hardware system you were working with, and I work with all of them. So then it was like, oh, you can't. You could do this, and I'm like, oh no, you can't, because it's actually an MXS 1.2. So now we don't have those differences in our hardware offerings.
I look at the new way of doing it, and I've been starting to mention and start to formulate a question. I wonder if we could build that same exact logic into the math channel, creation where we say, hey, I want it this channel and this or that, and it ends up building the math channel for us. I think that there's something there, and I've been starting to have that chat with the programmers in Emiliano. So I
Excellent.
think that would make some more sense than a comma, comma, and then have to understand that whole way of looking at math channels. So we'll see how it works out.
I would like to see some advanced math on board. I think that is that's a next growth platform. We
Yeah.
can definitely have some improvement on those aspects, and I really enjoy playing around with the math channels and making data channels out of other data channels that work for me. And if we could do that at the hardware level, it makes it that much easier.
Huge added value to every system. So
And from a dealer customer standpoint, our dealers can simply send a configuration with embedded math channels into it, so that way when the customers are downloading data, it's present in the data already. So it kind of gives some of our dealers a leg up
yeah,
if they're really good with those types of math
yeah.
channels.
Again, another added value for the from that dealer. Okay, what's in the box when you go to grab one of these?
I always think I always think of the movie "What's in the Box," Seven with Brad Pitt. In this box, it is electronics. So the EPM, it'll come with the CAN cable, which I was discussing earlier, and it has a built-in Binder 712 connector on there to plug directly into a data hub device. So it is ready to go. All you need to do is pin out the CAN high, the CAN low, and the ground of that cable to the EPM. So that would be pins 10, pins 11, and 22 on the EPM. And those are going to allow for the communication, the firmware updates, the data transfer, moving around status variables. Everything's going to transfer through those three wires. So when you're thinking about adding another PDM or adding a PDM to my build, maybe less complex than what you actually think, especially if you have all the sensors that you need for the device. It's going to be one cable to your data logging system. The Surlock connector is the same. It supports a 4 gauge cable, and it's designed to carry the brute force power to the PDM. So this is what you're going to connect to your battery isolator or your battery, and it's going to provide all of the working current for the PDM system. Now this can be live current, and you can have an activation with your ignition to turn on and off the PDM, where the power will just reside at the Surlock connector with no amp draw. So the amp seal connectors, the same as the PDM32, and the gold-plated contacts are a requirement. There's a variant of nickel-plated contacts, and we'll get into it, I think, in the next slide.
Okay, let's do that then. Boom.
So I put together a small infographic that has just some useful information with part numbers. I answer these questions a lot. What type of connectors are you using? What's the pin part number? I use these really nice back shells, which I put in there, and they allow me to basically secure a boot onto the back of the PDM, and it really allows me to seal that harness completely. So those are a nice touch for anybody building harnesses. The crimping, the output crimp tool, is going to be for your amp seal pins, and it is a two-part system. So you have the TE frame and you have the die set, and you can also purchase the combo and frame as a one tool. So those frequently asked questions, I thought I'd put them here so that they could live forever on the internet, and people can easily grab them.
Yeah, very powerful sheet here with a lot of information packed into a single page that it would take you a long time, take others a long time to get this knowledge that you have worked on for years.
Yeah. And then there's just a little call out. Gold contacts are the -3, and nickel contacts are they don't carry the same amount of amperage. So managing these is very important. We have a gold pin set on the PDM32, so it's important to match the metallurgies between the harness and the PDM32. So we're going to use all of the gold contacts. Could you use a nickel contact for a signal wire for one of your sensors? It would transfer information, but touching nickel and gold reduces the cycle count. So as you're like moving the connector in and out, you're not going to have the same metal types. One of them is going to be harder than the other, and it's going to eventually cause a problem. How long that will take, it's just better not to find out.
And it's going to vary by how many times you unplug it, right?
Hmm.
Matt just mentioned that this presentation is available for download. We've left the link into the live chat here. If you're watching this later on YouTube and you don't want to try to find this document, there will be a PDF of the presentation where you can grab this one slide and print it out if you wish. So, okay, what's the next slide here? Well, the next thing we want to do is talk a little bit about jumping out of the presentation and jumping in onto Robbie's live screen where he can show us a little bit about the configuration. We're not going to go deep into every single option, but I think he wanted to show us a little bit that way, right, Robbie?
Yeah. I just really show you how quickly you can get from a data logging system into a full race car build.
Okay, I'm going to stop my share. You can share your screen. And
Okay.
we see it. You're off and running.
All right. So here I had a pre-built one, but honestly I think we're going to go from scratch. So this is a brand new configuration. It's a steering wheel 4, and I think to me this is the perfect application for an EPM system. We have a steering wheel that has rotary dials, buttons, pass-through buttons. It's a data logger, and it has a digital display in there. So I do have it on my desk, but with my background, this
There you
right
go.
here, and you can see all of the buttons and the dials. Now, what do you do with all of those? If it's just your primary data logging system, you have to hit a button, and it sends out CAN information to something, and hopefully whatever you're sending it to can then manage it. We have that something now that the EPM will plug directly into it and become a supporting device for our SW4 that was already installed on the vehicle. So if we can come into here and into the software, we're going to go into the channels tab. I always go left to right, channels to CAN output. So that way I just know I didn't forget one, and it's almost built to allow that that left to right mentality, because the things that you're using, the channels, are the baseline. That's where we're going to start, and we're going to assign what we expect to do with our SW4, and then we have the power outputs, which are further down in the list, that we now are going to use our channels to operate. So in this situation, we have the clutch systems, the potential total current. This one here is only available if you select an EPM, and it will allow you to control or to record how much total current that EPM is pulling from or distributing out into the vehicle. So it's an aggregate number. So it takes all of the 32 power outputs and combines them together and says this is what it costs to run this EPM. So now you can kind of pair it against your alternator and see if you're going to be consuming more than what you're able to produce. So we will, for here, we don't have any of the clutch, we don't have left paddle shifts, and I always like to turn these off so they're not in my drop downs when I'm going to program things. But positional accuracy, speed, altitude, odometer, these are all valuable to me. So we'll go into our button configuration, and we have an active button map here. So when we're going through here, we can tell where it is on the steering wheel, what we're going to be doing. The main difference is these top right and left buttons, they say external. They're going to have a secondary option of being a pass-through button. So it's going to have a signal coming in that rests at one leg of the button, and then when you press the button, it's going to send it back out. So you think push to talks, or maybe a neutral activation, or something where we have to affect another device, and it can be as simple as sending them a ground. Now, if we want to manage a quick button, this is very similar to what you would find in the PDM, which is the big overhaul for 3.81. And we're going to have the toggle, the multi-state, and the momentary options. So for this, we're going to use a toggle because I only want to press it once to activate it. I don't want to continue to hold the button. So for this is the LED configuration. So when the toggle is in the on state, we are going to go into a green activation. and you can leave it programmed just like this, but you won't have a backlight. If you wanted to have a backlight, there's two different ways to do it. You can simply add the opposite. We can say off, and it will be white until I press it and it's on and it's green. Or because this priority, this is set up via priority, this can actually be always true, which is sometimes a little easier on the programming side of things. This is always true unless the button is on, in which it turns green. So this logic overrides the always true logic.
That priority thing is something that's we've been using that same function for quite some time, and a lot of people don't know about it. And I'm glad you mentioned it, because that adds even more power to what you're doing. Interesting.
And if you wanted to add an alarm, like we'll add another output state, and I'll prioritize this message. I can actually turn this red, and I can link it to the power output. Once we build that in there, I can actually link it to the power output. So if the power output fails, the button on the SW4 is going to turn red and notify me that I pushed that button. It's on, but the color is not, or
Yeah.
the color is not good.
Yep.
So we can save this now. We'll call this webinar button. Webinaire. Okay, so ECU stream, it's pretty similar to what we've always done. It has the sensor drop downs. So for this one, we're going to use our ECU. Don't mind all of the ECU ECUs in there. Now, we're going to go straight to CAN expansion. Now that we have an ECU, we set up a button, we're going to go straight into our CAN expansions, and we're going to add an EPM32. So here, this is I use these a lot, so they're always in my last configured, but we have them available. Everything that's compatible with the CAN expansion. So you'll see all of our keypads, our Rio devices, GPS modules, and the search function really helps kind of go through this. On new builds, you don't have a last configured expansion option. So on new builds, I can come in here and type in EPM, and it organizes the data so that organizes the images, so I only see what I'm trying to add. So we're going to add this EPM, and I'm going to make sure that everything is plugged in. So for this, I'm going to take my CAN cable, and it's a 712 cable. I'm plugging it right into my data hub, and I should be able to grab the serial number from this device. So available expansions, EPM32. Now there are other expansions here, but we do a really good job of assigning only the serial numbers that are specific to the expansion that you're going to be adding. So you're not going to see the keypad that's also on the bus or a Smarty Cam or anything. This is the only one that I can use for an EPM. And we have our additional channels. If I were going to be adding oil pressure, the SW4 doesn't have any analog channels on board, so you were always going to add an ACC3, especially for the non-common ECU supplied sensors, brake pressure, oil pressure, that are operated sometimes with just switches. They either have pressure or you don't have pressure. The EPM enhances the SW4 in a way that we now have 8 analog channels, so I can use my oil pressure and just keep the number of expansions to a minimum. So we'll set this up to oil pressure, and I always like the 0 to 150 psi's for that. And I'm not a decimal place fan. Some people are, some people aren't. Me, 58 psi, 73 psi, that's enough for me. So we've configured our channel. Digital outputs, you'll still have the access to the internal pull up and pull down. Now these are just switching devices. If I had a binary state that's coming in, a 0 or a 1, an ignition switch, like if I put a key in and it's either on or off, or a button that I want to add externally, I would add these here. And these are really good for signals to be coming from an ECU that tell you when to turn on a fuel pump. Let's say that's not available from the ECU through the CAN bus, but they do have a fuel pump activation output. Instead of hooking that up to a relay and managing it that way, you can pull this directly into the digital channel set. So you have 9, 10, 11, and 12. And now I can close to ground, use a pull-up circuit, and I'm going to set this as momentary. So this will be fuel activation, and we're going to do ECH, so I know it comes from the external or the EPM channel, and it's just going to be on or off. When the ECU tells us to fire it off, we'll be able to read this as an on or off state and do something with it. And I can turn on the current once I turn the power outputs on. One thing I really did want to we're going to kind of navigate away from the channels tab, but the status variables, one of the major features of adding an EPM is the increase to your status variables. These aren't linked to your master configuration. So the SW4, if we go into status variables, I have 79 available that I can program, and this is shared between math channels and shift lights and alarms. And you'd be surprised, 79 seems like a lot, but you run out very quickly, especially if you have 10 alarms. You have some math channels calculating brake bias. You have some status variables that are just recording different events, like if RPM is above 300 and oil pressure is below, or 3,000 oil pressure is below 3 psi. I want to log that in my data. That's great for status variables. So you fill these up really quickly. However, the PDM or the EPM32 has 127 variables that you can then begin to work with. So you can do all of your status variable programming in either of these sections. You could do it in the SW4 configuration, or you can do it so that it resides on the EPM, and this will save a lot of the processing capabilities and offload it to the EPM device.
And of course, those status variables are shared across the CAN network, so you can use them anywhere you wish. It's just you just have to be storing them on the EPM. It's a perfect world. You like adding that E?
It's like fixed. My hands type webinar with an E. The same condition, distinct condition, multiple output values. These are all now similar. You can find these in our EPMs, PDMs, as well as SW4. So this is the big update that we were talking about earlier. That kind of just made everything incredibly consistent. I mostly use the same conditions for activation and deactivation, and we can set them up with some program logic. So in this case, we'll do our oil pressure since we now have a channel. Now I have two devices here now, SW4 and the EPM, and I can grab information from either one of these just by clicking on this master device, and everything related to the EPM from the analog digital channels will be present here. And if I wanted to pull my safe ignition information, I would do so there. But in this case, we're going to grab RPM. We're going to say RPM greater than 3,000. And we're going to add a, let's see, oil pressure from our EPM. And we're going to say if this is less than 20 psi. Okay, now I have this status variable event that is going to make it easier for me to program the power output. I'm probably going to use this a couple of times in the configuration, and that's how I like to treat status variables. If you're going to be using the logic several times in your build, so if you have multiple circuits that are going to operate in the same way, I think like headlights, rock lights, fuel pumps, I'm going to have the same or very similar logic to turn them on and off. I'm going to write it one time, and I'm going to create a status variable. Then I just use that status variable in all of the power output logic. So I'm not constantly writing and rewriting and introducing clerical errors to my build. Now, this is very similar to the PDM32. So if you're not familiar with it, when you mouse over it, it's going to give you a snapshot on the right-hand side, and you can see what your programmable fuse is set to, whether you have the freewheeling diode selected, whether you're in pulse width modulation or square wave, and the logic that you're using to program it. It also highlights where you can find those wires on the build. So I know that my high power output, because it is over 15 amps, I'm going to have to use 2 pins for it, and those 2 pins are going to be 1 and 13, making troubleshooting a little bit easier. You're going to pull up your configuration and say, okay, well, I know that mid power output's failed because I have that wonderful RGB LED on the system, and it's told me it's not good. Now I can come into my configuration and say, okay, mid power output 8, I'm going to need to go to number, what was that, 10? It also says it right here. So it says B8. So this is the black connector, pin 8, and then the image on the side. So let's turn on our AccuSum. So I'm going to open up a power output channel. I'm going to give it a name, and in this case we'll call it Accu Sump. the naming convention that I use for the power outputs is the actual device. So whenever I have other things related to the actual device, I will put the designation of where it comes from. So you might have noticed I use SV or CH, and that's so when I'm looking at it, I know where it comes from, and that is due to the snapshot image that I was showing you earlier. Now in this case, we built a status variable. It lives on our EPM, so we'll select the status variable, and we'll say when this gets to S1, when this is true, I want to turn my power output on, and it's going to distribute additional oil pressure to my system because I am low on oil pressure. And so we've done it. Now I'm going to take a little bit of care going through some of these settings up here. You don't want to just leave these as their natural conditions. The maximum value requested, this is your programmable fuse. So I'm saying that this power output has 15 amps of current available to it, whether you use it or not. The AccuSump is rated for a 10 amp fuse, so I'm going to lower that to a 10 amp fuse. The overlatch off time is going to set your timed delay when you go over your programmable fuse. So if I go up to 10.1 amps, without this condition, the overlatch off time, this would break immediately and it would shut it down. But I know that I have 5 additional amps that I can play with, so I can actually go above my limit, and this is going to be the time. How long do I want it to go above 10 amps? Depending on wire size, how you've programmed it, and what it's going to be drawing, this is a dynamic number, and there's no right answer I can give you for all AccuSump pumps. It's going to be testing. Luckily, this is a data logger, so you're going to have all of the data, and you can play around with the overlatch current time. The number of retries is how many times I want to additionally try the circuit. So if it fails from short circuit, over current, over temperature, how many times do I actually try to reinitiate that circuit without the user doing anything? So this is an automation feature. I'm going to set this to probably 5 retries. Now the retry delay of half a second, sometimes it works really well. Sometimes you need to increase this number quite a bit. So if you separate it out for 5 seconds, then every 5 seconds I will click off one of these retry delays. Now, minimum current, this is if I don't want the power output to run under a certain amount of current, I'm going to put this minimum current in there. So it's like the opposite of a fuse. It's going to allow you to say if it's pulling less than 3 amps, then I know it's not really working, and I'm going to disable that power output, and then maybe allow it to switch. So in the case of fuel pumps, if I lose a fuel pump, I'm either going to have a whole lot of current that's drawn from the fuel pump, or I'm not going to have any current, and I can use this as a way to turn the power output off, so I can safely turn on the secondary fuel pump.
It's one way or the other. You mentioned a minute ago that you can check all these because you have the data, and that's a box up there in the upper left corner of record values. That's something that obviously has been added, and a lot of folks just we're to the point now where we just click that yes almost all the time, right? What do you think about recording of the values?
I record heavy consumers and things that are critical to running the vehicle. So I like to see the more data you record, the longer it takes to download. It just increases some of the time it takes to decompile and decompress after a race event. So rock lights, they either work or they didn't, and it's not going to be a huge concern if I don't need to pinpoint the exact time when a rock light failed.
No huge added value by knowing that as being recorded, but a low oil pressure situation, you do want to know exactly when that happened.
So in this case, I'm going to want to record, did my AccuSump turn on? Was it on or was it off? Is my logic working the way I expected to? Because if I misprogram my status variable or this power output and it never turns on, I'm going to want to know that something's going on with how I programmed it, and not necessarily that it was overdrawing current or there was a short circuit. It's just I programmed it incorrectly. That's what this recording value is going to. It's going to tell you the state of the AccuSump power output. Now the related channels is going to give you the status of it if you wanted to track if you were having issues with failing power outputs. It's going to give you a power output with a legend. So if you're recording a 0, everything's good to go. Short circuits, open circuits, high temperatures, overcurrent, under voltage, and over voltage all have a numerical value in your data. Now you can see exactly why it failed, and it'll help with your troubleshooting process. You can store those and the current. This is a big one for my heavy consumers. I always come into the related channels and activate my stored values for current so I can track overall health of it. Having historical data for a fan or a fuel pump, or I mean any pump really, water pumps, you can see that, oh, when I first installed this it was pulling 7 amps, and now it's like creeping up into the 9, 10, 11, 12 amp range as this is beginning to fail. And it can be a proactive approach to fixing your vehicle. So before you're left stranded on the side of the track, you're gonna know that something's going on. So
Yeah, very, very powerful tool. Kyle asked a question that I think fits in pretty well right here. Can you speak to the activated, deactivated for X seconds condition?
oh yeah.
I try to use these for oil PSI slosh, for example. It does not seem to work as I would expect. Talk a little bit about that activation and deactivation piece.
So we're talking in this section right here.
I believe that's where I think it was a slide earlier, but I think you're it's the same. I think
So this is
concept.
how to assess a valid state of your power output. In this case, we're going to set the status to on. We're going to turn the power output on when the following condition, which is what we've written in here as our status variable, is verified for at least 0 seconds. That's an immediate activation. Should that status variable become true, then I'm going to immediately turn the power output on.
Yeah, one
I
data
can
point above or below that, it's boom, it's off and running. Right?
So I can delay this activation and say it has to be true for something like 3 seconds. Now that variable that I'm using to control this power output has a condition, a further condition that says if it becomes untrue after 2 seconds, we're still not going to turn the power output on. It has to remain true for the entire duration of 3 seconds. This is a global setting to your power output. There's also ways to come in, and the true after time and false after time makes this condition dependent. So I can actually build my conditions to have that same logic. So if I'm building a multi-level power output that has activations from buttons, it has activations from sensors, it has activations from ECU data, I can say, okay, so I'm getting a little blip on my analog channel for oil pressure. So I'm going to say that this variable has to be true for 2 seconds. So that way it doesn't just constantly kick on. Maybe it was a sensor failing, something along those lines, but I can program that out. Now that does not, if I add a condition to it, it doesn't affect the next variable. So it's this independent variable timing and global timing. So this is for everything that I write in the logic, and this is for the independent logic itself. So
Very,
you
very
can,
powerful that way.
it's really great for buttons. If I want to have a momentary button, I can hit a button and say it has to be true for X number of seconds, and I can do something else in the meantime. It's an odd example, and I think I'll build a configuration that kind of supports it, but we switch between momentary and toggle systems a lot. And so you have these momentary buttons and you push and hold them and you get an activation. However, if you can create a status variable that changes that momentary into a toggle. Now I have two unique activations. I have an on activation that is momentary when I press the button, and then a toggled event. So I can actually say if I press this button, I want it to flash my headlights for as long as I hold it, but it also activates my siren, which is driven by the toggling mechanism for the SW4 and the EPM. So now I have two outputs that are using two different variables, but they all come from the same user input. So the customer just hits the button once, holds it if he wants to flash his lights, but his siren kicks on immediately and stays on until he presses the button again.
Robbie has taken us into the off-road desert racing world right there. So you're probably not doing that a ton in sports cars, but
Nope. This
and
would be a
then
good one
then you
for
have the
like
direct
racetracks.
opposite. You have the direct opposite as well, obviously, with the deactivation side, right?
Yep. And then the last two things is going to be the inrush current time and the number of retries for inrush. This is going to prevent a deactivation of your power output at the initial turn on of a large consuming device. So if you think of a fan that's stationary, it has to get moving, and the amount of current that we have to supply to the fan is increased substantially. So in this, I can program the fuse of the first activation event for a different value than my programmable fuse. And when the fan is running, I know that it runs at 16 amps. But when I first turn it on, thing's going to surge up to maybe 30 amps, and I can program this in-rush current time to allow the surge to happen on the EPM device, and this is how many times I would like to retry it if the system fails. So that is at the very beginning of your activation. This is the way that it will manage the power output after the initial activation.
Perfect.
Yeah, I think that's it. So we've turned on our AccuSump, we've configured channels, we've configured status variables. The next thing to do is to fill out the rest from here on out. And it's all very easy, very simple, clicking around, and that's it.
And these
We've
are
done it.
these are alive, right? They live. And you talked about a moment ago. You may build it, and the first time you take a crack at it, and then you go run the car, and you have stored some of these values. You come in after the race, the week after, and you study a little bit about when did things activate, when did they not, and you've seen the oil pressures and when the AccuSump hit. You go and you tweak it, you resend the transmit that back in for the next event, and you study that, and they get stronger and stronger and more valuable, right?
They absolutely do. Everything can grow as you learn more, and that's what I find helps me the most. Is that you do your initial baseline. I set it up. It has a configuration. It goes. It runs. It's a base file, and as the customer evolves his desires, we can come in and program this, which is a huge standout for PDMs. Instead of reconfiguring, rewiring, and retooling the car, I'm programming it. I'm saying, okay, now I don't want that button. It's hard for my finger to get to that button, but it's a very important thing. So I'm going to remap that button to another button that is easily accessible, and now it makes it easier for me. But I didn't have to rewire anything. I just came in and reassigned.
Fine-tuned.
Yep.
And I said that in maybe in the wrong way. I meant as much as if you were doing one that has done a bunch of them, you still fine-tune things because every car is slightly different. Every sensor works differently. Every user wants something different. And me being my first or second one, I should expect to run into that same thing where you just continue to fine-tune these things because they just get better and better. So that's the reason I said it the way I did. Okay.
Well,
Live measures. Let's talk a little bit about that.
yeah, this is another big 3.81 update that gives us a lot of flexibility. When we were talking about the related channels on the EPM, it becomes almost overwhelming with the amount of data that you have, data paralysis, if you will, because now you have 32 power outputs, and each one of those power outputs has a state, whether it's on or off. It has a current, how much current it's actually distributing to everything, and then whether or not that power output is healthy, whether it's short circuit, open circuit. So finding that information was somewhat cumbersome because it was a lot. Now we have 64 data channels that just in the power distribution, not including the analog channels or the ECU. So one of the major features is the search bar. This makes life a lot easier because I know that I called my status variable webinar. Did I send this configuration? I might not have. Yep.
Oh,
Okay.
yeah, you haven't seen it.
No status variables. It looks like we have a little bit of work to do. Let's try our Accu. There we go. Oh, I was scrolled down. That's what it was.
Oh, yeah.
Let's try the webinar again. Yep, there it is. So now I can easily find and sort out information that I'm quickly looking for with the search function, and we also group a lot of the power output information together. So I can turn my AccuSump on, and in this one data channel that I'm looking at, I actually have three. I have the state of the power output, I have the condition of the power output, and I have the amperage of the power output, all related to itself. And double clicking on this value begins a forced function. So if I'm testing my status variables, my program logic on the bench, or even in the car, I can come in and double click this value, and I can alter any one of these forced conditions. So if I wanted to turn it on, if I wanted to turn it off, I can click on these gears and just advance this to 1, and now my power output is on. Everything's okay. Nothing's connected now, so we're not pulling any amperage, but the system is functioning.
Allows
It's
you
now
to really deeply test things, really, sitting in the car, a week ahead of the event.
It really does. And also the same for your status variables. So you can advance this to S1, or you can even just put a numerical value 1 in there, and now my webinar status variable is active. So it helps testing with alarms and power outputs and really navigating around the PC side of things.
Very cool. Live measures, very powerful, not only in the AiM data logger world, but in the PDM and EPM world as well. Okay. Anything else you want to kind of cover there? We do have a couple of questions that we can kind of close with here in just a moment.
I think we try to close with some questions, and everybody should definitely experience the 3.81 build, because it's small changes, small quality of life changes that really enhance the software and the way that you interact with it. I really enjoy the new additions, and it's made my job a lot easier.
Jeff asked a question, do the PDMs allow for user configurable analog channel filter options, setting the filter cutoff, for example? I believe that's a no as of right now, right?
No, the only filtering mechanism that we have is like a desloshing mechanism for fuel floats.
We have a few extra, pre ones like that, and of course we have all the ones in Race Studio 3 afterwards in post. But only a few. It is one of the things that I know I have been pushing for a little bit as well. So I think we're working on it. Jeff mentions, do we need to worry about a fail-safe state if the EPM and dash lose contact with each other via CAN, I suppose, right?
If the fail-safe state is to keep the status quo, essentially. Now, if you would like to program in a mechanic that deactivates channels, it's all built into the power outputs. So I can come into my power outputs and I can say if safe ignition is no longer, if I lose the ignition leg, the PDM is going to shut down. I can put a notification on the SW4 that, hey, this isn't working. You're going to know that the PDM isn't working. However, the opposite is also true. I can say if we're not getting active communication within these two systems, I can now disable some certain power outputs if I deem that necessary. I haven't had a personal use case for that, but the feature is available.
Yeah, perfect. And Alan asked a question that I hadn't thought through at all, and I don't think it's possible, but we'll throw it out there. Can you script a startup test cycle through 1, 3, 8 independently, etc.? What do you think about that? That sounds like an interesting function.
So if we were to power up the system and then run through a test of 1, 3, 8, 12, and 16 power outputs, I'm assuming.
Yeah.
You can, however, it would be clunky and it would be an every time situation. So if you wanted to activate your fan, you could tie in safe ignition as an activation status. So once the PDM goes live, it's going to change the state of its safe ignition from 0 to 1. And now I can use this as an OR condition. If I turn the PDM on, safe ignition goes to 1, and for 5 seconds I want to run this power output based on the change in state. And that's where you would use the programmed timing functions in these. So I can come into, we'll do a mid-power output, and I can say that our safe ignition is equal to 1, and I can actually use the false time. So I want this is going to go true. So I want it to be equal to 0, and then I want it to go false after 3 seconds. So in this situation, when the value is 0 and it advances to 1, the condition is still true. So the PDM is now awake. It's going to distribute power for 3 seconds to your power output until the condition is no longer met, because it's no longer equal to 0 once the PDM's on. So I gave myself a 3-second timer to turn on a power output.
So you're able to program in some of these tests, but not in a true
not in a
script
way.
kind of a file that you run whenever you wish. So, but it's an interesting concept. I think maybe we should think about it.
It's the question. So automation. We touched on it a little bit, but I really enjoy the automation aspect of the PDM. So I can say, okay, I want to turn my fan on if engine coolant temperature is above 170 degrees. I'm going to start my cooling cycles and turning things on, turning things off. Now I always program in an override. So my SW4 in this case would have a button on it. I don't ever need to hit that button, but if I wanted to test my fan, I would have a button on the steering wheel, or if I felt like the fan needed to be on sooner because I'm going into a draft and I want to get ahead of the cooling that I know is I'm going to increase heat when I sucking next to somebody. So it's a great reason to add little tiny keypads. Also, these can be used as activation events, but also overrides.
And
Just manual
darned if what
checks.
you just said would you can then build a script of sorts. You could build it to a push button where you could run those 5 or 6 things
Hmm.
stacked in programmatically into one status variable and run them, right.
Yep,
So in
absolutely.
effect, you could. We wouldn't call it a script. We would just call it another, a running of a status variable or something.
Right.
Interesting. Solve that problem right there. No, maybe not
Right on
totally
the spot.
solved. Yeah, but we gave some options. I think it makes sense to me.
Okay.
Okay.
Well,
Okay.
I think that pretty much closes out for the screen sharing. So I can go ahead and hand it over back to you, Roger.
Perfect. Perfect. And you do that. And as soon as that goes away, I will share my screen again. And let's kind of close this one up. The as it's coming up, there it is. We've talked about some links today. I wanted to include those in the presentation materials in case somebody wanted to go take a look at the EPM and main page on our website, the technical sheets where we get some of the information that we did some screen captures on, documentation page where there's a number of different things. Some of the main webinars that we've done on PDMs and some of these topics are listed here, but also in the YouTube description down below, if you're watching this later, there will be a full list of links that we have included into the chat box here today for some of the folks that are watching live. So there'll be some additional links on top of what we're showing here. So that is pretty cool. The kind of closing this up, we're right at the hour, right? This video, like all the rest, will be going up on YouTube within the next couple of hours or so, as fast as I can get it up there, get it all put together, and get transmitted up to YouTube. So it'll be up there with a bunch of the rest of them. If you're watching this live and you haven't visited our YouTube page, it's just AiM Data. Go search there, subscribe to it. We're putting videos up there all the time, and there's 292 videos there right now. So there's a bunch of information that's been stored up there. So then the search bar inside of YouTube works pretty good, and I try to keyword in all of the descriptions areas where you can actually type in there and just put PDM or EPM, and it sorts pretty well for the videos that are up there. So use that search function. That should help you quite a bit. Customer support. Hey, this is SCCA runoffs week, right? I think our crew is arrived there for today, and they're full time working up at that large event. So, but we have folks that will be out at events almost every single weekend. Somewhere we have as many of our technicians at the events as we can do it. And if you don't see them there, call the 800 number. We're all about supporting of the products and making sure you get the most out of your investment into AiM products and software. So give us a holler, let us help you, and make some of this a little bit easier for you. So our next webinar is going to be October 14th. I'm calling it right now Anatomy of an AiM Support Call. It's really a data analysis discussion of we started at a certain spot and we walked our way through, and it just happened to be with a user that I found it was valuable for both of us to the process, and I thought it would make a good webinar to show, hey, we started here and we walked through these steps, and it's really a data analysis process webinar where we're going to talk about how to get from A to B. And I think it'll be fun for everybody to watch. We're going to talk about AccuSumps. Robbie jumped on that topic a little bit here today as well, and so we're going to talk about some of the stuff we found and resolutions to this user's issues over a weekend. So let's join us back here on October 14th. It's our evening one, 6 p.m. Pacific, 9 p.m. Eastern, October 14th. Look forward to seeing everybody there. It'll be a good time. It'll be I'll be presenting this one by myself, so this will be a fun one. The contact information, we've talked about a lot of stuff today. It's been a great time. I've learned a ton as we've gone, and there's some contact information down there below. Robbie's email address down there below, as well as mine. If there's anything that you may have some questions on that we didn't get to during the webinar, please give us an email and let us see what we can do to help you out. So Robbie, I appreciate you coming on here and doing this again. Is there anything that you might want to add as we're kind of closing this one down?
I'm interested in the anatomy of a support call. We might even roll
You
that
do a lot
into
of them. You do a lot of them.
onboarding.
Yeah, exactly. You do a lot of them, right? It will be interesting the different ways that information comes into us. So it'll be fun.
Yeah.
So, but we had a great time here today, and lots of great, strong information with a brand new, hugely powerful tool that I think is going to be very, very popular with a lot of folks. And I appreciate you coming on and talking about it. Anything else you'd like to add as we kind of close this one down?
No, in this, I just wanted to show the simplicity of adding a power distribution module. Perhaps in the future, if you have time, we could do a more comprehensive build, so walk someone through what it actually looks like to set up multiple power outputs and kind of use all of the devices together, set up a smarty cam. It's hard to compress that into an hour, but
Yeah. Well, I think we need to do this one first, and then I agree
Mhm.
with you. Maybe in a month or two, we'll come back and we'll do one where everybody understands how to put this together now. Now let's fine tune it and build one real quickly, right? And take that hour to build, certain channels and certain status variables, and add the smarty cam, all the different things. I think that will be and a keypad or whatever. I think that would be valuable. So we'll see what we can do. Okay, I appreciate it. I appreciate everybody that joined us here today. There were lots of great questions in the question and answer and in the chat. It was fun to do, and I appreciate that. And look forward to seeing everybody next time. Again, thank you, Robbie. Thank you, Matt, in the background. Answered a lot of questions and threw up a lot of links in the background. Appreciate you, Matt, and appreciate you, Robbie, for coming on. And we look forward to the next one. So thanks everybody for coming. I appreciate it, and we will talk to you guys soon. Bye bye.